Thank you so much for taking the time to join our presentation today. I'm Elaine Kwok. I'm the Senior Director of Marketing at Peak Power. And if you're not familiar with us, we offer a full end-to-end battery storage solution to reduce energy costs and pursue net zero goals. Along with our financing and development partners, we deploy, operate, optimize, and maintain battery energy storage systems for industrial facilities and commercial buildings. Our tech transforms large commercial buildings and industrial facilities into the cornerstone resources in a decentralized electricity system. And our creative financing approach is designed so our customers make money to be that energy resource. In the end, we all get cleaner, more reliable, and more affordable electricity. Today, we are talking about financing strategies for battery energy storage system projects. Our Director of Business Development, Archie Adams, is going to be joined by our Chief Financial Officer, Fareed Madani, to present this content and take questions at the end. Thanks, Archie. Now, if you have any questions that you'd like to ask, since we're going to run through this content as quickly as we can, otherwise 30 minutes, we want to protect your time. Please pop any questions that you have in the Q&A section at the bottom. And if you see a question that you want answered as well, please upvote that, and we'll be answering those in a priority sequence at the end. And with that, I will turn this over to Archie. Thank you.
Great. Thank you, Elaine. All righty. So yeah, excited to talk through this with folks on the call. Just a quick run through on the agenda. We'll be talking about savings and how projects work, sort of the costs that go into developing these projects, and then digging into the ownership structure and what makes a project work and why it works through incentives and programs to support it. So starting with the fundamentals and really how a project makes money, there are three types of energy cost savings: coincident peak charges. So there are different by region, but broadly, these are grid events where there's a ton of demand from facilities, from residents, and that's often driven by temperature and weather. Non-coincident peak charges, which are based on the facility's load and usage, those are sort of the facility's demand, and that we're using a battery to shave those. And then off-bill savings, so that's often programs like demand response or using the battery to participate in wholesale markets. So there's a few different ways, and you get into some complexity with the battery beyond just simple charge and discharge. Another look at these savings and sort of how they're how we look at them and where they come from. So as demand response, there's a whole lot of potential for savings here. And again, this is a program run through typically utilities that are sending a request to reduce facilities load. So rather than demand response in a facility curtailing load by interrupting business and, say, turning off equipment, we're using the battery to reduce the load in the background with no interruption to the facility. Demand management, so non-coincident peak, often called peak shaving, and using a battery to keep that the monthly peak demand below a certain threshold. Load shifting and peak shaving, so understanding when these valuable peaks happen, a lot of potential value here, and that's on-bill savings. Energy arbitrage, charging when the cost to charge is cheaper, and then discharging when it's higher. This is pretty active and a sort of lower potential, and then participating in reserve markets and grid supporting. So those are the sort of the fundamentals that will vary across markets, but it's happy to kind of share the brief overview of how we look at those. So that's how a project makes money. These are the costs that go into putting a project together. So projects are usually, the cost is usually measured by the kilowatt hours, the capacity of it. And that's going to typically range from 500 to 650 kW for this type of battery in this application. For example, we're talking about commercial industrial scale facilities in the 1 to 5 megawatt range. Larger projects may be cheaper, and smaller, for example, residential, will be much more expensive. So those costs kind of stack up. You have the battery itself, the supporting equipment, the inverter, the cost for the design and engineering, cost to install, and then actual construction, the permitting and regulatory compliance, and then integration with the existing facility infrastructure, tying the battery into the switchgear, for example, and then also integrating into the grid. and then the ongoing operation of the battery, the maintenance, insurance, et cetera. So looking at ownership structures, we'll start with self-ownership, which is where a facility or customer would purchase a battery themselves, and they would be investing their own capital to do that. So this diagram kind of shows this is the facility in the middle. You have a battery operator. You're typically going to need somebody like Peak Power or someone else to be operating this battery remotely to get the most return out of the project. You're working with vendors and suppliers, for the ongoing maintenance, the hardware costs, development costs, and then interfacing with the ISO and the utilities on some of those potential revenue streams, as I mentioned, and working with them on cost savings. So this may seem kind of like a simplistic sort of approach. The pro is that you're keeping the full savings and revenue for the host site. The drawbacks to this are that it's a huge investment, multi-million-dollar typically, into a project. You need to have the sort of expertise to operate and get the most out of it in-house. So that's adding either additional headcount or adding another task and responsibility to an already busy facilities management team. And then there are typically higher costs for sort of a one-off project. So if you're just looking at this for a single location, you don't really necessarily get the economies of scale or the experience from somebody coming in and doing this. I'll turn it over to Fareed here to discuss third-party ownership and more of what Peak Power does. Fareed, I think you're still on mute there.
Can you hear me now?
There we go.
Perfect. Thank you. So this is the value of where Peak Power comes in and other players like us. In this scenario, organizations that have the core competence of doing what they do best divide the value stream. So the customer, which is a facility owner, gives a right to develop a distributed energy resource, a battery solution or solar on their property. And a financier invests capital to build that battery solution on their property. In return for that, the financier gives part of the revenue that it has received back to the facility owner. So if you recall, there were some of the revenue streams that Archie had outlined in the beginning. The financier keeps majority of the revenue and the savings that come from operating the battery, and that's how the financier makes the return. Where does Peak Power fit into all of this? We facilitate the original transaction with the facility owner because we have financing partners who rely on us to bring opportunities to them. And we are able to design the system and we're able to structure the transaction. And we also optimize the software by which the actual savings are generated. So our software tells the battery what to do, and hence we help reduce cost and pursue towards the net zero goals. So we go to the next slide. What you see is the opposite of the cons that you saw in the self-ownership become pros here. So you don't have to invest any CapEx, you don't have to do any OpEx, and you get a turnkey solution. So there is no cash outflow, it's just a cash inflow situation. And in return, you have somebody who is investing capital on your behalf. When someone invests capital on your behalf, then they are looking to make a return out of that investment. And as a result, they need a long-term commitment from the host side that they will continue to operate as a going concern, as a live business, but also that they would continue to have either that load or an increasing load so that they can continue to make the money that they would have otherwise made. Let's go to the next slide. So important thing to highlight is as a commercial and industrial facility owner, the core business likely is not ownership of renewable energy assets, whether it's battery or solar. So the third-party ownership structure provides the ability for a commercial and industrial facility owner to get the benefits, not 100%, but a chunk of the benefits that could be generated from installing a battery or a solar at their site. And for a financier, it's an opportunity to invest in a renewable energy asset, which they would have otherwise not been able to invest because a host site has a land and they want to get some savings. Peak Power's value in all of this is we provide the turnkey solution. So the host site does not have to interface with any party. They just interface with Peak Power, who negotiates the contract with the suppliers, with the operating partners, with the financiers. So you get one-stop shop solution of having an asset on your site and then getting savings or emission reductions. So I will now turn it to Archie, who's going to talk a bit about some incentives, and he's going to talk about what the ideal load is. And there was a question in the Q&A about it as well, so we'll address that.
Sounds good. Alrighty. So I think just to highlight again what Farida talked about with a no cost or a third-party ownership solution, Peak is managing the financing of the system, and there's a share of this savings. So this means that us as a project operator are incentivized to maximize the value of the project over the course of the agreement. We're sort of aligned and expecting and sharing in the upside as the project grows and markets evolve. It also means that the host customer is offloading some of the technology risk, meaning that you're not investing in a battery that might, there may be changes in technology. That's on us as the project owner and operator. And then supporting the development. So from the start, Peak Power, third-party owner, is the counterparty at the table with the customer. And we're incentivized again to maintain and maximize the value of the battery for the course of the agreement. So I think helpful to note that not every site qualifies for this. It's really we're lining up some key factors here to make this work and be able to offer this with zero cost to a customer. When we can do that, these are off, saving 40 to 80K annually for customers per megawatt of installed battery. But to do that, we need to have a customer that has an on-peak demand of typically at least a megawatt or greater. And that often means, it's a rule of thumb, they're paying about at least 50K per month in bills, which means that there's a large opportunity for savings there. It is very helpful to have the customer own the facility. So it's a little bit more complicated and messy to work with a landlord. We're looking to work with host customers that do own their site and want to be there for a long time. So we can work on installing a product there for a minimum of 10 years. The metering, so typically looking for a single meter that's then sending power to the entire facility. You think about an apartment building with a bunch of sub-meters, it's difficult to capture the value there because a single battery wouldn't be able to serve the same load. So it isn't a great fit for multi-tenant kind of spaces, but a sort of a large industrial manufacturing facility or a campus with a single meter and the load behind that, we tie the battery in right behind that meter and manage the overall load. And then the last key to make an ideal project work is siting. So there's been lots of interest in New York City, and unfortunately that's a challenging, sort of very dense urban area because there's not a whole lot of space. These batteries are not large, but there's still not a whole lot of space on Manhattan sidewalks for batteries these days. So looking at areas outside of urban areas, suburban, often corporate campuses, manufacturing facilities are a little bit further outside the city, and those are a good fit for us. Just a note on US federal incentives. So the federal government is really heavily incentivizing projects like this to work. So Peak Power has the key party in this is working with the financing party and the customer, capturing that tax credit and the value that's designed to encourage these type of projects to work. And that is sort of baked into the overall costs of the system and how we build it, which in turn reduces or increases the savings share to a customer. And then the makers, I don't know how you guys pronounce that, but that's depreciation over 70 years. So which is also pretty key to maximizing the value of a project. Also helpful are these key markets and areas that we really know where projects work. It's interesting, they're all sort of driven in slightly different ways. For example, Ontario is very much based on the global adjustment coincident peak, whereas California out west is really maybe a more advanced market structure where you're more opportunity to be shifting demand around time of use rates while also supporting a grid. And then here in Massachusetts, there's sort of a stack of programs and opportunities for battery to generate savings and revenue. So it does take some flexibility on how we operate these assets. And that's one of the big advantages of energy storage as opposed to just a solar project is we are able to alter and update our operating strategies to capture the full value as markets evolve over the 10, 15-year deals. All right, so that takes us to the Q&A. And I see we do have some questions here. So let me take a look and let's see. Does Peak Power offer other commercial models for financing a battery energy storage solution? For example, a price floor, an operating lease, or tolling structures? Reid, do you want to take that one?
Yes, I can take that. So we offer other commercial solutions when we have a solar and battery solution combined. It is determined based on how the financier is underwriting the risk. Generally speaking, if it's a more stable market, and if the customer is willing to pay a power purchase agreement, host site, then we can offer financiers different commercial solutions instead of just relying on market prices.
Thanks, Fareed. So the next question, how do you manage the likely risk of the global adjustment program being adjusted to eliminate five peak days and replacing it with a simple peak load at any time? Do you want to take that one, Fareed?
Absolutely. So I would say that generally speaking, the regulatory risk is underwritten by the financier. So at this stage, although there has been discussions about the GA program, there is a consensus that the economics of GAs will not change dramatically. So the regulatory risk is underwritten by financiers, and to the extent we operate in a stable market, the financiers take the regulatory risk on the revenue streams.
Thank you. I'll take this next one. How many hours of storage is provided as a minimum? So it's an interesting question, and I think it reflects the varying nature of the markets we're looking at. So, for example, in California, those are typically 4 hours because the resource adequacy program, that's kind of demand response type program, does have 4-hour call windows. So we want to be making sure we're maximizing the value of the project and the system by reflecting the opportunities. If we're calling and forecasting peaks, coincident peaks, that may be slightly lower than 4 hours. So it does vary by market. Okay, Fareed, the next one for you. How does Peak Power manage the merchant risk of long-term agreements? And is there a minimum guaranteed revenue for Peak Power?
Absolutely. So similar to the previous answer I gave about the GA, the risk is underwritten by the financier. So these are our financing partners. And I'll also use this opportunity to address the question that Hector, you're asking. So we are the developer and the software operator for the battery. In the ownership scheme, the owner of the asset or the person who's going to deploy the capital is our financing partner. When the financing partner invests the capex, they are looking at what they're getting in return. Most of the revenue streams that we talked about earlier in the presentation are regulated. So they have been implemented by way of either a legislation or by way of a policy. So the financier takes a view on the stability of those revenue streams. In other cases, the host site can provide a power purchase agreement. And if there is not a power purchase agreement, then there is a risk for merchant prices. But as you would have seen from the earlier slide, we see energy arbitrage as a small component of the revenue stack, which means that the exposure to merchant prices is low in how we select the sites and how we operate the sites. So minimum guaranteed revenue is for peak power. There's a commercial structure between peak power and its financier. But to the extent your question was, is there a minimum guaranteed revenue for the financier, for the actual investor? There may be if there is a power purchase agreement. So what we would offer to think about is, as a commercial and industrial client, if you want to save your energy costs or if you want to reduce your GHG emissions, the question is at what cost and under what structure. So if you would love to get a fixed price so that you can eliminate all the volatility, we can do that. If you want to get a GHG emissions, we can do that. So the commercial structure will depend on the needs and how flexible the commercial and industrial facility is.
Sounds good. Thanks. And I'll mark this as answered as well. This next question, what is Peak Power doing to increase adoption of battery storage in Ontario for residential and commercial customers? I would say we're not focused on the residential space. It's definitely a different solution and approach. We're on the commercial and industrial space, so more focused on the 1 to 5 megawatt customers typically. Read anything to add on that?
Absolutely, absolutely. And the reason why we are not focused on residential is because the solutions that we operate in need space and needs a tariff structure that works for the financier to make money. So residential at this stage does not make sense. CNI, based on the criteria Archie outlined up before, makes sense so far.
Yeah, maybe someday we'll be calling peaks for residential. That it certainly is interesting, or seeing more markets shift to a time of use kind of structure, but yeah, not residential at this point in Ontario. Question on a per megawatt basis: what's the financial consequence of dispatching off peak? So I'll take a quick stab at that. I think that there's other reasons to be dispatching off peak if you're trying to capture maybe a grid supporting revenue, if there's a need for it. The immediate financial consequence is the cost to charge the battery. So that's the big one, and in terms of a major cost. But we do strategically, optimize how we're charging and then discharging. So there could be an opportunity or a situation where we would be discharging off peak, but more typically would be targeting on peak and valuable hours there.
Absolutely. And the only thing I would add to what Archie said is we have a demonstrated track record of over 5 years of doing it at more than 95% efficiency, depending on the market, of dispatching properly and being able to predict those hours, and then getting the savings or the GHG reductions that we had that we were solving for.
This question is about an 8-hour operating duration. So typically we are looking at up to 4 hours. 8 hour, I think, falls into the long duration energy storage category. And often you're getting into different technologies beyond lithium-ion batteries to do that. There are trade-offs and it's sort of a different use case when you have that sort of 8-hour capacity. You could buy that with lithium-ion batteries and stack them up that way, but more typically you're seeing alternative chemistries for an 8-hour operating duration. Main challenges that Peak Power faces developing energy storage projects in the focused markets you mentioned. I'll just say quickly, I would say interconnection. I think that's the low hanging fruit. I don't know if you have anything to share as well.
Absolutely. I think that is the long pole in the tent for all markets, not just the small markets, the small assets that we focus on, but even for larger ones, that is the biggest challenge globally.
Question about shared savings paid out month-to-month basis. Just quickly, I think oftentimes some of the savings is actually on the customer's bill in terms of demand charges or potentially the capacity tag associated with the account annually. So some of that on-bill savings is that way. I would say that the project revenues coming from demand response will be a little bit less month to month and maybe more based on seasons and performance. So it maybe would be market by market to answer that. And then I think this is probably based on timing our final question here. When there's solar plus battery, so solar plus storage, does the software control dispatch strategies for both? It's an interesting question. I think the way we view it is that solar is obviously fairly predictable. You're going to be getting a whole lot more from 10 a.m. to 2 p.m. Typically. So we do take the forecasting into account as we're managing our charge and discharge strategies. But it is both, absolutely. We can't really do much to discharge solar and get more sunshine. So we're typically kind of managing around what we have for solar production. Okay, I think we're basically at time. Just one more question though. The typical long-term contract period. It's probably 10 or 15 years for a standalone storage project. It will be longer with solar because those assets do last typically 25, 30 years. So longer for those and will vary slightly by market.
All right, and I'm taking over because it is time. Thank you so much. Thank you so much, Archie, and thank you so much, Fareed, for providing this great educational content and for answering these questions. Thanks, all you attendees for joining and for asking such fantastic questions as well. We will be sending this recording out to you as well as an ebook that we've just created that covers all these topics. So please look in your email for those as well as for a post-webinar survey. So let us know what you want to see from us. We are going to keep doing these webinars and we want to make sure that they continue to give you some value. So thank you so much, everybody, and have a great rest of your day. Bye-bye.
Thanks, Elaine.
Thanks.